Hello everyone, let's solve a practice question. So this is the question: find the linear transformation from R3 into R3 which has its range spanned by these two vectors. Okay, so the basis of the range is given. Okay, so these vectors are forming the basis of the range. So basis of the range will be the set of these two vectors. Okay, and we need to find the linear transformation from R3 to R3. Okay, so suppose T is the linear transformation, so we need to find T, that is from R3 to R3, and we know the range of the basis of this transformation T. So this is again a question from your UPSC optional paper 1, okay, maths paper 1. These questions are really important because UPSC and in other competitive exams the question like this are framed. Okay, so we need to solve these questions very carefully. Now we know the basis. Now just take the standard basis of this R3. Okay, so standard basis of our R3 will be what? Will be the set of vectors. So this will be the standard basis for R3, right? Now if we take any two elements, we need to form a transformation so that these two vectors form the basis of the range. Okay, so if we take any two vectors from here and we assume that these two vectors are mapping to these two vectors respectively, suppose that T of our first vector from the basis is mapped to the first vector of the basis of the range, that is T of 1 0 0 is equals to 1 0 minus 1, and again the second vector of the standard basis is mapped to the second vector of the basis of the range, that is this. Okay, so T of 0 1 0 is equals to, okay, and we can assume that this T of our third vector from the standard basis, that is T of 0 0 1, is nothing but equals to 0 vector. Okay, so this sort of consideration is true because we are getting the range as these two vectors and they are linearly independent, as we know that they form the basis of our range. Right here we have the third vector that is mapped to 0 vector, right? So as for this point it is good. Okay, now what about the general vector that we have in our domain? Suppose that W is the general vector from R3. Okay, so what is the transformation of this vector? How can we represent this vector on the side of the range, right? As we know that any general vector in R3 can be written as linear combination of the basis elements of R3 and the standard basis element. The standard basis of our R3 is having vectors that we defined above, these three vectors. Okay, these three vectors are the vectors from the standard basis of R3, right? So we can write W is equals to alpha 1 into our first vector from the basis plus alpha 2 into our second vector from the basis plus alpha 3 into our third vector from the basis, right? Where alpha 1, alpha 2 and alpha 3 are nothing but they belong to the field. And what will be the field of the R3? That is R. Okay, so we can write it like this. Now if we'll transform, we'll take the transform of this vector it will become transform of this whole thing, right? Okay, so it will be right. Okay, and since t is linear transformation, we have t of alpha into v1 plus beta into v2 plus gamma into v3 equals to alpha into t of v1 plus beta into t of v2 plus gamma into t of v3, right? So this is basically coming from the definition of linear transformation. Okay, so we can write this whole thing in this form, right? Okay, so t of w will be equals to what? Alpha 1 into t of our first vector from the standard basis, alpha 2 the second vector from the standard basis, plus alpha 3 the transformation of third vector from the basis, right? And this we already know, this and this we already have assumed that these are mapped with the basis element of the range of the transformation, that is here. From here we get transformation of 1 0 0 vector, transformation of this vector is equals to this vector, and transformation of this vector is equals to this vector, right? And we know from there we get transformation of our third vector is equals to 0 vector. So we can write this whole thing as alpha into plus beta into our second vector from the basis plus 0, right? This will become, so this will be alpha 1 and alpha 2, sorry, this will become alpha 1 plus alpha 2 the first coordinate, the second coordinate will become 2 alpha 2, and the third coordinate will become 2 alpha 2 minus alpha 1, right? And this is it. So if we have any general vector, suppose w, then this will be our transformation, linear transformation, where these alpha 1, alpha 2 and alpha 3 will be from our field real number. So this is the transformation and this is the answer basically. These alpha 1, alpha 2 and alpha 3, they are nothing but the constants or the scalars that we got when we represented w in the form of our basis elements. We represented w as the linear combination of standard basis element of R3, right? So these alpha 1, alpha 2 and alpha 3 are those constants, okay? And these constants or the scalars or components of vector are coming here again, okay? You can rewrite it in a better way, that the whole thing again, that if w belonging to R3 and w is equals to alpha 1 1 0 0 plus alpha 2 0 1 0 plus alpha 3 0 0 1, then t of w will be equals to the same transformation we got here, okay? that is alpha 1 plus alpha 2, 2 into alpha 2 and 2 into alpha 2 minus alpha 1, right? Okay, so you can write it in this way. It looks better and it is very conclusive also. Okay, so this is our transformation, linear transformation that we were required to find. Remember that this transformation is not unique. Okay, you can get any other transformation also. So this transformation basically depends on our assumption that we have taken here. The whole transformation depends on this assumption, these three assumptions. So if you would have taken transformation of this first vector from the standard basis as the second vector from the basis of the range, then the transformation would have gone different. And if you would have taken the second vector as 0, the transformation of second vector as 0, then it would have gone different. So it depends that what you assume, but the method, the whole process to find the transformation should be similar. Okay, I hope you got the understanding on how to find the linear transformation when the range is given. Okay, so again I am repeating it. When the range is given, you need to find out, you need to assume that the standard basis of the domain or the vector space, okay, the standard basis of the vector space here R3 are mapped to the range element. Okay, range element, or I should say the basis of the range. Okay, and after that you need to use the definition of your linear transformation and find out the transformation for the general element of the given domain vector space. Okay, and that will be the transformation of that will be the linear transformation that is required. Okay, so I hope you got the understanding. If you have any confusion, just write down in the comment section and I'll be replying to those comments as soon as possible. Thank you for watching. Thank you for your time. Subscribe to my channel. Thank you. Bye.